There's so many factors to take into account when you're trying to work on mechanisms. And this is a new factor to take into account. On problem 656, we know that a three-membered ring is highly strained. And so it's very hard to make a three-membered ring, hard to keep a three-membered ring intact. However, it's surprisingly easy to make because of the vicinity of possible nucleophile in the leaving group. Now, what I mean by that is this. Let me look at this example up over here. In this case, we have a really good nucleophile and we have a good leaving group. And this, so here we go, delta minus, delta plus, and we have an actual negative. And again, whenever you have a negative, you're looking to attack. One of the other fundamental things is always intra versus inter. Intramolecular reactions are always faster than intermolecular reactions. Now, in this case, this oxygen is like right over here, negative, and right there, really close, is a carbon that's slightly positive. All you have to do is apply a little bit of energy, and because of the vicinity, because they're so close to each other, this is surprisingly easy to make. Now, we're going to end up forming a three-membered ring over here where this oxygen, and we're going to learn all about epoxide. This is called an epoxide. And then the Cl minus comes flying out, and that's the end of the story for that type of reaction. Now, in chapter 19 or so, I forget which one it is, there's a whole chapter dedicated to amines. And I'm always going to tout that you're looking for negatives to attack, but amines are a special case. This nitrogen right here is partially negative, and the chlorine here partially negative, that carbon partially positive, but an amine is a pretty good nucleophile. And so if you add a little bit of energy, it just kind of has to bend back a little bit. Imagine, a couple people right here, just the next person over is a little bit behind you. All you have to do is kind of stretch and they're right there. So this will go ahead and form an intramolecular SN2 reaction in both of these cases over here. Intramolecular SN2. Intramolecular SN2. Because of the proximity, they're so close to each other. And now you'll get a three-membered ring in which the nitrogen is positive here, and then we have our ethyl group, our other two groups. Now the difference between the epoxide, which is much more common, and this three-membered ring, this is very esoteric, I guess, is that once this forms, this nitrogen is positively charged, whereas up here the oxygen was neutral. And the positive nitrogen means that it's going to be a pretty good leaving group. And so now the chloride that came flying out is going to go ahead and attack and open this up, and it's going to attack from either side, either the left side or the right side. If it attacks from the left side, let's just do the left side right here, and then it's going to do that, and we're going to get boom, 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 a chlorine here and an NH2 group over there. If it attacked from the right side over here, we would end up getting a chlorine here and an NH2 group over there, back and forth.